Good morning. My name is Joshua Olunlade, and this work is co-authored with Dr. Moses Olayemi at the University of Oklahoma. I want to start with a number because it's the number that basically motivated this entire study. An entry-level engineer in Nigeria earns somewhere between 110 and 220 US dollars a month when you convert it from Naira. And a single annual SolidWorks professional license costs somewhere between $2,800 and $4,700 in a year. That means that a graduate would need to spend somewhere between 128 and 214 months of their entire gross salary. Put in another way, they would need to save for about 12 years or thereabout to be able to afford 1 year of SolidWorks professional license. This is not a pricing inconvenience when it comes to a graduate level engineer that they learned how to use the software throughout their undergraduate journey. Nigeria's new curriculum is beautiful. It has its impediments, but it's beautiful in most ends because it requires students to do a lot of things that are now in the 21st century. So one of those things is the GET 102 Engineering Graphics and Solid Modeling course. It's built around the idea that students should learn how to use CAD software, parametric 3D CAD modeling, design thinking, different things like that. The intent is really good, and the challenge is that this assumes that most institutions have access to this software and that most students maybe can afford it. So the biggest challenge is what happens when the students cannot afford it or when institutions cannot provide them with it. That's why in this study, we asked the question, can FreeCAD, an open source tool, a free and open source software, do exactly what the proprietary software would have done for this course? So what did we do? To answer the question, we used a mixed method design with 3 parts because we wanted both like technical evidence that this software can do this and also real student experiences. So firstly, we did a curriculum mapping. We took every learning outcome that was required by the curriculum for GT 102 and we tested it hands-on on FreeCAD 1.0 at the time to see if it could actually deliver on all of those features and learning outcomes. Secondly, we did a cost benefit analysis. We compared FreeCAD against 3 platforms that students would usually encounter in school: Fusion 360, Autodesk Inventor, and SolidWorks, on licensing cost, on hardware requirements, and on something we termed 5-year total post-graduation cost of ownership. Third, we surveyed students who had just completed the GET 102 course using FreeCAD as their primary tool. Over 100 students were enrolled in the course, but only 23 responded to the survey. It's a small sample, but it's enough for an exploratory study, especially combined with the other 2 strands of what the study also did. So, in the aspect of curriculum fit and curriculum mapping, does FreeCAD actually work technically? Can it work for this course? The beautiful thing is that FreeCAD offers full support for about 53% of the things we listed out that a CAD software should be able to do. It can sound like a weakness that it can only do 53%, but if you look at the 53% that it supports fully, you would see that every core competence that GET 102 requires as a course, orthographic, isometric projections, sectioning, basic parametric 3D modeling, and the likes, is fully supported by FreeCAD 100%. What is missing or partially supported are things that, like design thinking. Design thinking is not something that can be fully supported by any individual software. That is to be learned. And then you have other advanced things like iron surface modeling, simulation, a full standardized assembly workflow, and things like that. And honestly, these are not disadvantages, because these are skills that should be built higher up in the curriculum. So it shows that for a for a first year course, FreeCAD can offer a very good alternative. So the real finding is not that FreeCAD is 53% as good as other software. It is that FreeCAD is exactly sized to actually fulfill the requirements of this course. In fact, if you look at it, FreeCAD is not underqualified. It is a little bit even overqualified for this specific GT 102 course. In terms of cost, access, and student voices, the question is, does it actually work for the people using it? On the cost side, I think we think it's evident. FreeCAD has zero costs, at least to download the software, to get it, zero cost, $0, versus thousands of dollars of annual licensing fees per year. But just as important is the hardware. FreeCAD runs comfortably on 4 gig of RAM. Inventor and SolidWorks, they want 16 gigs minimum, and they also usually need a certified graphics card. That is the difference between every student can run this on their machine and only the university can run it on only a few devices during lab hours. And students actually felt that when we asked them about what they liked most about the course. One of the things that kept on coming up was the freedom. Basically, the ability to be able to practice by themselves at 11 p.m., 2 a.m. with their own laptops without worrying about license expiration or piracy, which is a real thing in many places that are underfunded. On the numbers aspect of things, students rated FreeCAD's adequacy for meeting the course outcomes at 4.22 out of 5, feature sufficiency at 4.3 out of 5, and the one that surprised us the most is that students that had already used other software like AutoCAD or SolidWorks before rated FreeCAD as 87% equal or better than the other commercial tools for learning the fundamentals of solid modeling. In fact, one student put it really simply after working through FreeCAD. So the student said that after working through FreeCAD with its demanding workflow and things like that, FreeCAD wasn't an easy path, but it helped them to understand the fundamentals. Eventually, 91% of students, when asked if they would recommend this to the next cohort, said an emphatic yes. So what do we do with this information? This has been an exploratory study, so it cannot be generalized to all situations and all circumstances. So there is really need for more research into these kinds of things. Can free and open source software aid in the democratization of education? Can FreeCAD be used as the primary platforms in first year and second year where students are still building foundations, and proprietary software can be used maybe later on in year 4, 5, 3, and the likes? That does two things at once. It protects the educational quality from budget cuts, and also it protects the educational quality from exchange rate shocks as well. It also means that a graduate that knows how to use CAD isn't held hostage by a particular software, but they are versatile in using different kinds of CAD modeling software. So to balance this, we may say that there are student licenses available for software like SolidWorks, Inventor, and the likes. But the question is that when the student licenses expire, when students graduate, how do graduates afford this software? We need to build a system where our graduates can do work from what they have learned in university without necessarily facing an impossible barrier. So this is not about settling for this is good enough. It's a strategic resource for sustainable engineering education. Thank you very much, and I am happy to take questions.